At Ocean Controls, we distribute several brands and types of proximity sensor. There are many variants and it can be confusing to find the most suitable part for your application. Here, I will briefly explain the selection criteria and some simple use cases for the sensors in our range. Firstly, you can select the detection type based on what material we need to detect. There are three main options for this: inductive, capacitive, and photoelectric. Photoelectric deserves its own video, so for this scope we will cover inductive and capacitive. Secondly, you will need to find a suitable output type. The common outputs are PNP, NPN, or dry contact outputs. Put simply, inductive sensors will detect metal objects when they are within the detection range. You can see on the graph on the left here, we have some standard metal types, which inductive is perfectly capable of sensing. Different metals will require different mounting distances, and it is generally meant for iron and ferromagnetic materials. Whereas capacitive sensors can detect metallic and non-conductive materials, they are a better choice for detecting liquids or other materials such as grains or food products and more. Next is the output type. We have our three main types here. Conventionally, it is either NPN or PNP. PNP outputs will actually short this switch here, which will push a high voltage signal through to your device, which will be attached to the negative supply. An NPN sensor is the opposite, such that your device will be attached to the high voltage, and the NPN sensor will close this switch here, which will short the ground connection from your device. A less common type is our 2-wire, which is normally a reed switch. This can basically be treated as a relay output, such that this switch will close and the output positive and negative terminals will be shorted together. If you have any confusion with the electrical portion of these types of outputs, feel free to contact us directly. Here we have a small example use case for some proximity sensor. We're using a lead shine stepper motor. Here we have a photoelectric sensor, which will be talking to our Novus tachometer here. The pulses output from the photoelectric sensor will actually measure the RPM on the motor, and we'll see that on the display. Then in the bottom right, we have our inductive proximity sensor, which is serving as a limit switch, such that the gantry can't perform any over travel. We can see 300 RPM, and our motor hits the limit switch and immediately limits travel.